Hello and welcome to today's presentation and demonstration. My name is Andrew Price from Infrasoft and I'm here with our partners Comforte to introduce you to uLinga for Kafka, which provides high-performance streaming for non-stop applications and data. In today's session, we're going to go over a brief introduction to Infrasoft and to the uLinga product suite. Then we're going to look at uLinga for Kafka in a bit more detail. We'll have a demonstration of uLinga for Kafka, and we'll have some time to talk about next steps. Firstly, introducing Infrasoft and the uLinga product suite. So Infrasoft was formed in 2009, and we specialize in all forms of mainframe and legacy and even modern communications, including SNA, X25, and all the way through to HTTP and REST. Our company founders have been involved in the non-stop and the SNA and mainframe since the early 80s. uLinga products are sold and supported worldwide by Comforte and also by HPE. And our products are in production at major installations around the world across some of the verticals that you can see listed on the screen. We often get asked, what is uLinga? Where does that name come from? uLinga is an Indigenous Australian term meaning to fly. We think that that's a good attribute for a solution suite that represents transforming technology, allowing you to protect your investments in your business logic while moving seamlessly to modern, open, and industry standard networking and communications. This is a quick view of the entire uLinga product suite. As you can see from the top, it runs on a variety of different platforms. Today's focus is predominantly non-stop, understandably, but we do support Linux, Windows, and Unix. We have our host connectivity solutions over here on the right, uLinga for Kix, uLinga for Enterprise Extender or EE, uLinga for IMS, and our new uLinga for Kafka product. And on the left-hand side, we have our encapsulation products, DLSW and X25. All the products support a wide range of access points, and we'll talk about some of those access points in more detail. All the products provide non-stop fundamentals, as you would expect. They support industry standard protocols. Where applicable, we provide a comprehensive SNA implementation, but everything we do is IP-based to allow for easier problem determination. And being IP-based gives us options for security, TLS, and IPsec. We have a modern web-based graphical user interface called WebCon, which we'll see today in the demonstration. Our IMS and Kix products adhere to the IBM standards for those products, and we provide a wide range of APIs, both on non-stop and on other platforms, to support any application. Probably one of the most important points of the product is how extensive and comprehensive their inbuilt tracing and logging capabilities are. And as I've mentioned, multi-platform running on those platforms that are listed there. The way we're able to do this is by providing a core that all the uLinga products utilize, with some of the features that you can see listed there. Over on the right-hand side, we have our connection points, which is generally around the way our products are packaged. We can connect to mainframes via EE or IMS or Kix. We can connect to Kafka and some of the other options that we've mentioned below. And then on the left-hand side, we have the different ways that you can access uLinga. Your applications can access uLinga to get their data sent to these different connection points. And we have some non-stop specific access points and some more general access points that work across all platforms. So now to introduce uLinga for Kafka specifically. Firstly, an introduction to Kafka itself. Kafka is the most popular open source stream processing software for collecting, processing, storing, and analyzing data at scale. And that's from the Kafka Apache project website. Kafka is used by thousands of companies. Users include some in the financial space that we're fairly comfortable with, some of the names listed there, and also some of those very, very well-known household names. Moving into the non-stop space, we believe that non-stop applications will become a very valuable source of data for Kafka, and we need a highly performant and simple integration solution to get that non-stop data streamed to Kafka quickly and easily. So uLinga for Kafka acts as a Kafka producer, streaming data directly to a Kafka cluster. And the difference in how we've implemented uLinga for Kafka is that we support the native Kafka wire protocols over TCP/IP. That means there's no additional software required, no interim servers, no possible risk of introducing a single point of failure. And everything we've done is written in C, so there's no Java, so we can get the best performance on nonstop. uLinga for Kafka runs like any other uLinga product, runs as a nonstop process pair under Guardian or OSS, and is managed via the browser-based utility WebCon. And the great thing about this is we know that the uLinga architecture can and does handle massive data throughput in some of our large production implementations with our other products. And in fact, even uLinga for Kafka, we'll talk about, is able to handle massive data throughput as well. As the product exists today, it provides 3 different access points to give options for your different applications. The file reader access point allows uLinga to read data directly from inscribed files. The IPC access point allows a client application to send data to uLinga explicitly via IPC or PathSend. And the HTTP access point allows client applications to send data to uLinga via HTTP and REST. And in our demonstration, we'll go through each of those so you can see how they work. So moving into the demonstration, the first capability we're going to take a look at is that file reader support that I mentioned, whereby uLinga is able to do an end-of-file chase on an inscribed data file, maybe an entry sequenced file or a relative file, and pick up records as they are written to the end of that file, and simply stream the data from those records over TCP/IP directly to the Kafka cluster. Looking at the internals of uLinga for Kafka in a little more detail, here we have our uLinga for Kafka process. Within uLinga for Kafka, we have 2 logical resources that are responsible for this behavior. We have the file reader resource, which is responsible for knowing which inscribed files to monitor, and for reading new records as files are written, as new records as they are written to that file. As those records are read in, the file reader resource then routes those to the Kafka producer resource, which is configured with Kafka cluster information, broker, topic, etc., to forward that information, to stream that information to Kafka. So to see what this looks like, we're going to bring up our WebCon session, which is our browser-based user interface. You can see from the dashboard, I have a file reader configured and it's running. And I actually have 2 Kafka producer resources, and we'll look at each of those throughout the demo. But for now, if we have a look at the file reader resource called FR1, you can see that the file reader is configured to look for files that match this template, $infra.apkafka.file*. It's going to keep the most recent file open and monitor that file for changes and read in new records as they are written. Send those records internally to this Kafka producer KP1. And the Kafka producer KP1 is configured to talk to this broker with this client ID and this particular topic. And we'll see all of that on the Kafka side in a second. Okay, so we've got file reader going to Kafka producer. Once again, the file reader is looking for files named like this. So if I go to my 6530 session, and you can see the most recent file there is called file 38. The simplest thing for me to do is just create a new file. Let's call it file 39 in that way. And if I go back to WebCon also includes an EMS event viewer, so you can see all of the events that uLinga for Kafka is issuing. You can see that uLinga's found file 39. It's closed file 38 and moved on to 39, reading that from the start, and it's processed the records that were in that file, and it's now sitting there waiting for new records to be written. And as any new records are written, it will be reading those and sending them over to Kafka. So to see what's happening on the Kafka side, we're going to use a product called Offset Explorer, which shows our Kafka data. And you remember that the Kafka producer was going to this topic called triple topic. We have 3 partitions, hence the triple topic name. And if we click here, we have to wait for a second or two because Offset Explorer is a little slow, but we will see the data that is returned. And you can see at 10:53, which is my local time, all of these records were being streamed across at a fairly rapid pace. So that's how we read records from an nscribe file and stream those as they are written. Let's move back to our demo slides here. From nscribe file to file reader to Kafka producer and to Kafka cluster. The second capability that we want to look at is for path send and IPC support. So this is where an application might want to explicitly send one or more records to Kafka, and it can do so by opening uLinga directly, and it can send either a path send or a server class send or a Guardian IPC by opening the uLinga process directly. And anything that uLinga receives via that path send or IPC connection, it will just simply stream straight across to the Kafka cluster. Looking at the internals again within uLinga for Kafka, we have the same Kafka producer resource, which is responsible for identifying the topic and the cluster information. Now we have this new resource called IPC server raw, which is the mechanism by which raw IPC messages come into uLinga for Kafka. So we could have a Guardian process opening uLinga directly, or a path send client doing a server class send to uLinga for Kafka, and anything that uLinga receives on that resource, it will be passed to the Kafka producer resource and then forwarded from there to the Kafka cluster. So if we go back to our webcon, we want to see the IPC server raw resources. We have this one here called Kafka IPC, and you can see the open name is #Kafka1 or #Kafka1. So an application wishing to route data through this open name would open $APULK.#Kafka1. Anything that comes in on that open name will be routed to Kafka producer KP2. Okay, KP2 looks like this, very similar to the other producer we looked at, but a different topic, my topic. Okay, so we just need to get some data into $APULK.#Kafka1, and it will go across to be streamed across to Kafka. The easiest way to do that is just to do a FUP copy. I have a very simple file here called FUP test that has a single record in it. And if I FUP copy that FUP test to $APULK.#Kafka1, one record is transferred. If we go to our event viewer, we will see that an incoming IPC connection was accepted with #Kafka1, and then it was disconnected when FUP stopped. And if we go to our Offset Explorer, remember this was a different topic, my topic. We have a look at our data. Wait for a second for Offset Explorer to wake up. And this is my local timestamp, 10:56, with that record. This is a test of FUP copy data to Kafka. So that's taking data from a file via a FUP copy and sending it through to Kafka. Now, that could be a much larger file, or it could indeed be a Guardian process or a pathway server, a path send client, sending that data to $APULK.#Kafka1. Anything that comes in on that open qualifier, uLinga will forward directly to Kafka according to its configuration. The final access point we're going to look at with uLinga for Kafka is the HTTP access point. Using this mechanism, any application, either on the Nonstop or on another platform, can forward data to be sent to Kafka via HTTP. uLinga will act as the HTTP server and take the payload from that HTTP request and forward that data from the payload straight to Kafka. So that could be something like an API gateway, the new HP API gateway product running on Nonstop, or it could be on another platform anywhere. And in fact, uLinga could be running on another platform as well. So this could be a Linux server or a Nonstop server, an API gateway on another platform, or indeed any HTTP client on any platform forwarding data via an HTTP post or put. uLinga will extract the payload from that HTTP request and forward it directly to Kafka. In this situation, the configuration internally within uLinga is a little bit different. We have an HTTP server resource which configures the IP address and port that uLinga is listening on for that incoming HTTP request. And then we have one or more HTTP path resources that are used to resolve the entire URI of the incoming request, and from that URI map to a Kafka producer, which in turn will map to a topic on Kafka. So using this mechanism, you could have different URIs to stream data to different Kafka topics, for instance. So the way that looks, if we go to our webcon, so we have an HTTP server resource called Kafka Server, which is listening on port 24445, the default IP stack. So in fact, this is going to equate to 10.0.0.173 port 24445. So my webcon's on 24444. The HTTP server is on 24445. So anything coming in on that port, uLinga is going to try and find a matching HTTP path for the URI that it's received. So if we have a request coming in with that path or that URI, Kafka path, that will be found by uLinga and mapped to this HTTP path, which in turn routes to this Kafka producer, which is the one that we looked at before, the topic of my topic. So once again, we want to send in an HTTP post or put with that IP address, port 24445, which is from the HTTP server, and then the URI should be /Kafka path, and anything that comes in from that path will be routed. The payload will be extracted and routed to Kafka. So let's see that in reality. Now I'm going to use SOAP UI to initiate an HTTP post. You can see I've got that same IP address that we were just talking about and port 24445, and my resource is Kafka path. And let's just say we want to send some data like that, and we want to do that as a post. So let's click play. That's my local timestamp, HTTP 200 OK. So let's go to Offset Explorer and see whether that data's arrived. So this was the last data that we streamed over. Let's click play to retrieve the latest data. Wait for 10 seconds for Offset Explorer to do its thing. And there we see TBC demo post number 1. That's just gone across again. That's local timestamp, but yep, where I am right now. So that's how a simple HTTP post or put can be used from any platform to send data via uLinga for Kafka to Kafka itself. And of course, all of these capabilities can be used in conjunction with each other. So you could have an environment where you're reading one or more files and those are constantly being streamed to Kafka. Your Guardian application could be explicitly sending events throughout the day whenever needed. And then you may have another client running on another platform that also needs to get data through to Kafka. It can be sending that via HTTP. So any and all of those options are possible at the same time. So in summary, uLinga for Kafka provides excellent performance as it's written in C and has no additional software requirements, no interim servers required. In fact, in our initial internal testing, we're seeing performance of greater than 10,000 records per second streaming to Kafka with sub-second latency, so excellent performance. We also provide all of the same advantages as you would expect from the other uLinga products, being well proven, adhering to the non-stop fundamentals, being fault tolerant, scalable, and so on, and also including extensive tracing and diagnostic capabilities. And finally, as we've seen in the demo, the webcon browser-based user interface. There are a variety of mechanisms to input data into uLinga for Kafka and from there through to the Kafka cluster. We've talked about those today. The file reader that supports nscribe files, the IPC mechanism that allows Guardian and OSS processes to send via $receive, and path send clients to perform a path send or a server class send to get their payload routed directly over to Kafka. And also the HTTP mechanism that allows any HTTP or REST clients to stream data via uLinga from any platform, nonstop or any other. And uLinga for Kafka is in EAP now, so please contact us if you'd like some more information, and we'll be very happy to work with you. If you want any more information, there's my contact details. Feel free to contact me anytime, or indeed contact any of your local Comforte offices using the information that's on the screen. And then finally, I think we have time for some live Q&A. So if you have any questions, please go ahead with those now. Thank you very much for your time.